Hey everyone, welcome to another episode of Behind the Dashboard, where we look under the hood of a specific feature, talking to members of the Catchpoint pit crew who do everything from crank out the code to place the finish line. In each episode, we're going to take an express lane past the technical congestion caused by focusing on speeds and feeds and dive into the conversation to the destination IT practitioners want, discussing what the technology is and what problem it solves. And joining me today on this journey of discovery is Brandon DeLapp, our leader of solutions engineering. Welcome.
Hi, everyone. Hi, Leon. Hi, Sergey. It's a pleasure to be on today and looking forward to today's session.
It is great to have you. And also, as we just introduced Sergey Katsev, the totally not intimidating VP of engineering. Dun dun dun.
Thanks for stealing my thunder, Brandon. Hey, everybody.
Perfect. Okay, so before we dive into the work, we are whole people who have lives and jobs and stuff like that besides being on videos. At least you do. I seem to be on a lot of them. But I want to hear a little bit about what does it mean to, like, what does a day in the life of your job look like? And also, what's going on in your life that's not work? Just a little bit. Sergey, since Brandon clearly cannot be trusted to steal thunder, Sergey, you go first. What does VP of engineering mean exactly?
Sure. So I head up the product engineering teams that develop the Catchpoint products. So all of your standard agile software engineering processes, right, that people have probably heard of, creating this SaaS platform, software as a service, multi-tenant platform that we call Catchpoint.
Very
So
cool.
I've been here for 8 years. I guess I really like it.
Cool. Anything exciting going on that's not work?
So yesterday I dropped my kids with the in-laws for 2 weeks. So my wife and I get to go and enjoy life as adults
What?
for a little bit of time, which is wonderful.
Wow. Okay. Party at Sergey's house. Fabulous. Okay.
Come on over.
All right, Brandon, we can now trust you. So first of all, leader of solutions engineering. What's that all about?
Yeah, so I lead the solutions engineering team from a pre-sales perspective, and what that means is we're the SEs that hop on those discoveries, those demos, help our clients walk through trials, proof of concepts, essentially see them the initial value of catch points, and get them onboarded to catch point and show them new features, new products, new functionality, new use cases that obviously the engineering team is helping build into the platform.
Nice. Okay, and have you gotten rid of your kids this summer?
No, I have not. A second one on the way, actually. So that's some new
You're
news. But
you're busy adding them in. Okay, got it.
exactly. I'm at the point where I'm
Congratulations.
adding them in, and he's trying to remove them.
They'll be
But
back soon.
But some other cool things going on. I'm actually going to see Fantastic Four tonight, so that'll be nice. It's
Nice.
trying out the new XD D box seats. So apparently the
So
seats move with the movie, and I don't know. It should be cool.
what?
So this is an amusement park
No.
and a movie theater.
It seems like
That's
it, yeah.
For some
I'm
reason.
waiting
I'll
for
let you know
like
how it goes.
when Ben Grimm
So
says it's clobbering time, like the entire
Right.
so tune in for the next
Exactly.
episode where Brandon
Right. Yeah.
reviews his experience.
that's
Exactly.
a whole different video series. We're gonna do like Catch Point After
Yes.
Dark. We're gonna talk about movies and stuff like that. All right.
Perfect.
But it can't all be fun and games and D box seats and things like that. We are here today to talk about Traceroute. And it's a funny, just to kick it off a little bit, Traceroute is a funny little technology that is both old and also seemingly simple, but there's a lot that it can do. And I know a lot of people who overlook it and dismiss it. So before we dive into all the cool stuff that Catchpoint does related to Traceroute, can one of you give like a quick explainer? What is Traceroute, its history, stuff like that?
Sure, I can do that. And I will do that using a slide deck from a couple of years ago. I hope the audience forgives me,
Oops.
but you know what? Traceroute is like 38 years old, so the slides haven't changed much. Traceroute 101. So in the before IP, you can kind of see where this terrible joke is going. Computers were directly connected to each other. They could just talk to each other. So if you needed to troubleshoot a problem between computer A and computer B, you can just say, hey, computer A, talk to computer B. There's nothing in between. You can easily identify hops because there was only one hop between the computers. You can identify the delays. You can figure out if there's packet loss. Everything is easy. And then, of course, AI after IP, we have routers, right? And so routers have extra hops. And now we have to figure out, okay, well, which path is a packet taking? Are all of these other devices that we're adding between the client and the server introducing latency, introducing packet loss? Those are the main two things that we care about with traceroute. And of course, complexity, right? So when ARPANET was becoming the internet, right? So what does that say? 1984.
Let's zoom in. There we go.
Thank you. That's what the internet looked like, right? That's it. Those are all of the nodes or the computers on the internet. While the picture on the right is actually from a few years ago, so it's even more complex now. But as you can imagine, there's millions and millions and millions of devices on the internet that are all talking to each other with lots and lots of routers and hops, and there's a lot of complexity. So going really, really fast. Complexity necessitates tools. And the tool here is traceroute. So how does traceroute work? Well, it turns out that in IPv4, very analogous stuff going on in IPv6, but just to make it easy to understand, there's this field in every packet that's sent across IPv4 called time to live, TTL. Every time a packet is sent, the sender specifies the maximum time to live, and then every time that packet goes across a router, it's decremented. And so if you specify a time to live of 20 and you go through 3 hops, by the time it gets to the end, it's 17, right? And so this guy, Van Jacobson, this is his quote from the original traceroute program he wrote, cobbled up a program to trace out the route to a host. Send a UDP packet with a TTL, listen for a time exceeded message, right? Because that's how networks work anyway. Once the TTL hits 0, you get a time exceeded and you can tell what was going on the way to the destination. And so you send multiple packets, one with a TTL of 1, you'll get your response from the first hop, one with a TTL of 2, you'll get your response from the second hop, etc. And you can trace out what's going on that way. And that's what this diagram is showing. So just skipping ahead here, this has... So Unix was the reason that traceroute sort of became necessary, because Unix was the original thing that allowed computers to talk to each other, right?
So they were the original routers. Yeah,
exactly. Unix came in the 70s, IP came also in the 70s, ping came in 83, and then traceroute in 87. And then since then, there have been a bunch of enhancements to traceroute, again, because complexity. As the network changes, the internet changes, we have to keep changing the tools that we use to analyze them. So I'll pause here and we will continue the lesson a little bit later.
Okay. So that's a basic, a more than basic overview of traceroute. I guess the next question is, why don't, I think everyone has used traceroute before. Actually, does Brandon, do you want to show? You've been very quiet. I don't want you to feel ignored. Do you want to show what traceroute looks like? Is that
yeah? I could definitely open up a terminal quick and show them what a traceroute would look like from a single user perspective. So here's a terminal on my Mac. So as you can see, I'm sure a lot of you are familiar with this. What this allows you to do is run all sorts of different commands. From a network perspective, obviously ping, but what this session's focused on is traceroute. So as an example here, I'm just going to go ahead and type in traceroute, and I'm going to type in a popular domain here that I want to reach. So, this could be anything that you're doing on your, your laptop, your day-to-day at your job, in office locations, things like that. So let me go ahead and execute that. So as you can see here, what it's telling us is that first hop, obviously being within my network there. And then I'm leveraging Spectrum. So obviously Spectrum is built off of Charter. And you can see that in the old domain and host names there. And we can see the IPs. And then finally, you can see, all right, where's that closest server from a Google perspective that I ended up? So in this case, I am in Los Angeles. And you can see by the naming scheme there, but we can also do that via an IP lookup, but we do see LAX. So in this case, it took about 30 milliseconds for me to reach the closest www.google.com server. This is a very helpful tool. As I mentioned, right, it could be anything from, I'm having issues trying to reach or trying to access some sort of service. It could be, typical IT help desk trying to figure out why a user is having local internet issues within an office, things like that. The longer the path, the longer it takes, the worse my experience could be when I'm trying to actually access that digital service.
Right.
Yep. And one cool thing that we've sort of alluded to but haven't explicitly mentioned, traceroute comes with all of the standard operating systems, right? So if you have a Windows computer, you have a Mac, you have a Linux computer, it already has traceroute built in. So it's a great troubleshooting tool. Brandon, on that screen that you had there were a couple of stars I saw. What are those all about?
Yeah, definitely. So what that means is obviously we've gotten some packet looks. So along the path here, we've seen some of these routers that didn't necessarily respond to that ping that we sent alongside that trace route. So this is extremely helpful. Obviously, it indicates, it could indicate some issues with, network paths. It could be congestion. Different protocols could lead to multiple series of hops that are indicating packet loss that don't necessarily indicate a problem. So that's also some areas where, this individual tool doesn't necessarily get to the point that you're trying to get to when it comes to resolving an issue.
Yeah, and that's exactly where I was going with that, right? So, yes, the stars mean basically that you never got the reply back, right? And sometimes you get the stars right away. Sometimes you get the stars after some kind of timeout, maybe 5 seconds later, right? So traceroute can take a very long time to run if you have a lot of firewalls, for example, in the middle. And so firewalls, if we can go back to my slide deck, are actually one of the things that cause headaches for traceroute. Because what happens is, since the main way that traceroute works, the original traceroute algorithm, at least for TCP, is that it sends out a bunch of SYN packets. I'm not going to get into a whole lot of detail of how TCP connections work, but the first packet to establish a TCP connection is a SYN packet. So since there isn't already a connection, it goes and sends out a bunch of them, while a firewall thinks that that's an attack and it blocks them, right? And so that's one reason that complex modern networks, you end up with traceroute not necessarily showing you what you think it should show you. One other example of complexity that breaks traceroute is load balancers, right? So with a load balancer, I'll actually use this one as an example. A load balancer lets you connect to one or more destinations along your path. And so in this example, the first load balancer here can send you to either router 2 or router 3. Then this load balancer here can send you to either router 5 or router 6 in order to get to the server, right? Well, with a trace route, let's say you send a trace route from the client and it goes through this load balancer and takes the top path. All right, great. But then when you're actually connecting to the server for real through a web browser, let's say, you take the bottom path. Well, you're not measuring the thing that you want to be measuring. You're not measuring the user experience. You happen to accidentally hit some other path, right?
And to be honest, the internet is multipath. So half or a third of your packets may be going top route, and a third maybe and the other 2/3 may be going bottom route. And so you're getting like hippity hoppity, like, you know, the top path is good and the bottom path is really slow. And so your application response is like,
Yeah, exactly. And all sorts of other crazy complexity depending on the different applications and protocols, right? And everything. Maybe one more example of complexity here are NATs, right? Network address translation. So inside of corporate networks, inside of just networks in general, usually the addressing scheme is different than the outside world. There's usually one or a handful of external IP addresses and a whole bunch of systems inside. Well, so usually that means that you can't trace route inside of the network because there's no way to do that translation in that direction, right? You can't translate from one to many. Usually that means you could trace route outbound, but not always. For example, there's a kind of famous bug with Azure Cloud Services. If you try to trace route to an Azure system, because of the way that Azure handles NAT, traceroute just doesn't work. And if you ask Microsoft, which we did because we have a lot of customers that are using Azure, we also use Azure, they tell you, oh yeah, traceroute doesn't work, just use ping.
Sure. Yeah, because that's totally the same.
Here's the support ticket.
Oh my.
So the short version is, if you want to use traceroute, you should use traceroute. And so we at Catchpoint actually fixed this particular problem. And where I'm going with this is, yes, traceroute is available on everybody's computer, but there are different versions of traceroute. And so we actually created something called Pietrasanta-traceroute, named after our beautiful office in Italy, because traceroutes tend to be named after places where the developers are. So we created Pietrasanta-traceroute a couple of years ago and added all of these enhancements that fix various problems: firewall problems, load balancing, path selection problems, network address translation problems, and many more. And by the way, this is all open source, right? So we would love for you to be a Catchpoint customer, but even if you're not, this is open source. Go download it to your laptop, play around with it, give us feedback if you want.
I think what's interesting about this is you've answered the next question, which really is like, why doesn't people? Okay, traceroute's on every machine, just run it from there. Okay, fine, but except it's not perfect in the form that we get it on our Windows or Mac, or probably better than either of those Linux. Not that I'm biased. Laptop, machines, that you could use a different one. So that's. But it's still sort of the same version of the question. Great, download Pietrasanta for traceroute and just use that. Like, why do we try to make it a bit? Why do we put it into our app? Like, what's our point of view that it has to be inside Catchpoint? What does that do for us?
Yeah, well, I think the main thing here is, the internet is complex and it's fragile.
Sure.
It always breaks, right? And so we looked at this earlier. Well, now let's add multiple clients. Before we had a single client talking to one server, right? But that's probably not the situation that you care about as an IT practitioner. If you care about, hey, I, Leon, want to talk to google.com and it's not working and I'm going to run traceroute from my laptop to google.com and figure out if there's a network problem, cool, do that. But you probably care about sure, your connection, but also every other customer that you have. And maybe it's not google.com, maybe it's leon.com or whatever your personal site is.
Adado Systems, if we're doing that. Actually, I care more about my daughter's bakery.
You're welcome for the plug.
Loveplusflower.com. There we go. There's the advertisement. Keep going. Sorry.
So since you care about all of them, you need a way to figure out, can all of them get to that website or that internet service, whatever it is, right? And so whether it's this client or this client or this client, and by the way, if you have thousands of places or millions of places where your customers are accessing your server from, you can't be sitting there going, okay, does this work? Does this work? Does this work? Right? So you need automations, and you need visibility from those vantage points, and you need a way to analyze all of that data together. So maybe Brandon, can you show us how one might do that?
Yeah, definitely. Let me go ahead and jump on over here. So jumping over to the Catchpoint platform here, and this is where I can kind of talk through bringing Traceroute to a scalable solution and how that can really give you as a network operator, network engineer, get you the data that you need to prove that it's not the network. So what you're looking at is over 3,000 agents available to you, spread across different network types. And that's also very, very important. Being able to make sure that you have a point of presence connected to a specific network that end user or client is actually coming from or originating from. So how we do this at Catchpoint is we spread this across different types of networks, and we classify these within the portal, starting with backbone. What these will be, and you actually saw some of these on that Traceroute that I ran. So these will be those core ISPs within these cities and countries and continents. So for example, here stateside would be like AT&T, Cogent, Spectrum, Comcast, Verizon. We also go a little closer to the consumer ISP, so the actual Spectrum connection that I'm connected to here. And we have what are called last mile agents available to you. So these are dedicated Catchpoint servers where you can start executing these trace routes on an ongoing basis, 24/7, 365. So whenever you need to get a good idea of how are your users from a network perspective potentially experiencing your platform, these are always on and available to you.
And I think, sorry, Brandon, I think that's
No
a really good point also that we didn't mention earlier. Yes, if somebody calls me up and says, hey, I'm having a problem, I can go and teach them how to run a trace route from their laptop. But with monitoring, the goal is to solve the problem that's going on right now, but also to watch for trend shifts, to watch for historical differences, right? And so it's super important to be doing this continually all the time in order to see when something changes, to see if there's a micro outage that maybe is going to become a macro outage, or to see if maybe there's a very slow degradation in performance that you wouldn't catch otherwise just doing it, maybe once a month from your laptop.
Right. Or to put it in a business context, you want to know that the network in a particular location is having a problem and be able to roll a truck before the store opens its doors at 9 a.m. Before users are actually on the system. So that's the concept of synthetics, but it's also the concept of having all these points of presence, is that you'll know when a network is degraded before people are actually banging on it. And the other point I wanted to jump in and say is that, yes, you could teach somebody how to do traceroute on their laptop, but it's much harder to teach someone to do that on their phone. Yes, I know you can do it. I know 1 million Android users are screaming at me right now. I'm one of you too. Don't worry, but it can be done, but it's not something you want to be telling your 7 million app users to be doing to help you troubleshoot the problem. Sorry, keep going, Brandon. The interruptions.
No, and that's actually a good segue, because the actual next network type that I was going to cover here is wireless. So we do have 4G and 5G locations available where you can run those trace routes from. So for example, here, right, from Manhattan, right, or Boston here, you have the ability to run from, a Verizon, a T-Mobile, and that will be running from the IPv6 wireless infrastructure. So like you mentioned, right, you don't need to actually have your users run a trace route from their mobile device. You can actually run it from one of these Catchpoint locations in these core cities. There's also use cases. We do have cloud agents available to you. There are payloads that are cloud to cloud, right? They may never actually reach the end user. So we haven't really touched on that here yet. But that is a capability here from within Catchpoint, right? We have these the top cloud providers available to you from a global perspective. And if there are any payloads within your application or service that are, in between multiple clouds, we have the ability to run tests between those as well.
Yeah, I think it's
good.
Rewind. Yeah, I think that we always think of the internet as, a person using a computer that is on the other side of the world. But the reality is most of the internet nowadays is machines talking to machines, right? APIs talking to microservices, talking to other APIs, etc. And yeah, there's hopefully some kind of human use case at the end of that chain, but the actual communications are machines talking to machines. They might both be in the cloud. They might be in multiple clouds. They might be in different factories in different cities around the world, right? And all of them need that fast communication between each other.
Right. All right. I love the background, but I'm at the point where I want to see what does it look like? Like, okay, fine. We understand what traceroute is. We understand where it came from. We understand where it doesn't stand up on a command line or on a single machine. And we understand why Catchpoint wants to get involved, but what does it look like in the portal when I'm doing is the dots it? He said, setting Brandon up to show that it's absolutely not just the dots.
It's not just the dots.
What's going on here?
Yeah, no, definitely. So let me go ahead and jump over into the control center quickly here. I just want to show you a test that I set up before the call here today. I am leveraging our traceroute in session monitor. So that's going to make sure that the TCP connection is established. So again, similar to what Sergey mentioned earlier, and some of the pitfalls and some of the enhancements, right? This is one of those monitors meant to, overcome those pitfalls with a typical trace route. We do have other protocol types here available to you to test. So depending on your application, depending on your use case, Catchpoint can support that from these different monitor checks that we have available. And last but not least, before I move on here, would be the frequency. So obviously, from a network perspective, the more frequent you can run, the more data you have to figure out, where is that latency coming from? Where is that packet loss, jitter? How granular can I get here? So Catchpoint does have the ability for you to execute these at a minute interval, and you can obviously select as many as the locations that are important to you and run those from within that frequency. Excellent. So let's jump over now into the smartboard. Now, a smartboard within Catchpoint is a single dashboard, a single view that allows you to drill into a test. In this case, I've selected that Google traceroute test. We're looking at the last hour of data here. This gives you a great snapshot of the metrics that pertain to that specific monitor. So in this case, round trip time, jitter, and packet loss are key indicators of poor experience along the network. We do store this in its most granular format here. So you have the ability to actually switch over to a scatter plot, look at the round trip time, look at the jitter, the packet loss, any outliers. Where do those outliers come from? So in this case, Atlanta, Lumen. You can also switch over to a nice geo map here, which quickly highlights where we may be seeing complete failures from a traceroute perspective. So you can see here a provider within Colombia, Telefonica, or Chile, sorry. Geez, my geography is not up to snuff here. Jumping over to the network tab. So this is going to be that final view, right? The final dashboard view here that I want to highlight on this session, and it's going to be putting that map of all of those trace routes that we're executing from those different points of presence that Catchpoint has available to you, going to google.com, and how many IPs you can see are actually behind that single domain that I'm trying to traverse. So left to right here, obviously introducing any alike peers or ASs. So we can see here that Lumen peering with level 3 to get into Google's AS. Within this single visualization, we do have a lot of different filtering capabilities. So for example, if we want to just look at, show me where there's a packet loss, which specific path is experiencing that, you can quickly do that. If you want to see any sort of, ECN change or MTU bottleneck, you can quickly filter to that individual path and go back to the main view. So this visualization allows a network engineer to quickly drill through all the different trace routes that we have executed over a certain period of time, and also allows them to get down into, at the end of the day, is it a single server or IP behind my domain that may be causing the issues, or is it a peer or AS that may be contributing to latency?
Nice. And I think what's also important to emphasize here is that, we started off at the beginning of this video talking about traceroute as just a command line utility that you can run to try to dig into, like, why is this one little thing happening? And what we've done is transformed that using the massive number of endpoints that you can bring to bear, but also the data collection and data visualization to a really powerful monitoring aspect of your monitoring. And that was the point I made at the very beginning, is that traceroute tends to get overlooked, because I think that we who are IT practitioners know traceroute from I just typed the command in my keyboard. But when you leverage, again, the data storage, the normalization and the visualization to it, all of a sudden you realize how much raw information is really there, right?
Exactly. And what's also helpful is we can not only show you the broad view, right? The overall, how are all my users potentially experiencing, that's my network at that point in time, but we also have the ability to drill down into those individual records. So that single view that you saw from my terminal, you can also see that view from within the Catchpoint platform in its granular format here. So we have the ability to, as you can see, break it down by hop. You can see which IP address, where's the location, which AS, as well as those additional path MTU discovery and MPLS labels depending on that network, and then finally getting to that server that responded. So the combination of having that granular or having that aggregate view, and then also that granular view, and being able to quickly share these results via public link is extremely helpful for network engineers, to prove that it's not the network, and then also potentially, include that in some sort of escalation to a third-party provider to fix an issue.
Yeah, and Leon, you asked, hey, why not just run this on your own laptop, right? So running it multiple times, you can kind of figure out jitter or some of these other things, but Catchpoint's going to calculate all of that for you, running it from different vantage points. You probably don't have that many vantage points, right? So Brandon talked about over 3,000. I'm guessing people don't have access to that many systems to run traceroute from all over the world. And then the last piece is all of the different ways that we enrich the data, right? So for example, on this screen, you see the location there. So we do the geo lookup and tell you where is it in the world that this is going through, which for example is very important when you want to see, is your path somehow mapped to the wrong place, right? We've seen situations where traffic from New York to California goes through the Middle East. That's either a hijack or a leak or a a misconfiguration typo somewhere, but that certainly shouldn't be happening. And so catching that using a platform like this is very helpful. And then even things like within some of the cloud hyperscaler infrastructure, we enrich the data and show you what is it what services it's going through inside of the hyperscalers.
Yeah, it's okay. Really cool. All right.
There's
Before
more
we
that could
wrap,
be said.
there's a lot more that we could say, but I want to keep this relatively short to focus on this one thing, which is the point of behind the dashboard. So before we wrap up, this is what I affectionately call the lightning round. Any final thoughts, anything that you want to make sure that people take away when they walk away from this video? They're like, but I remember that Brandon said or Sergey said. I'll start and say, first of all, it's never the network. Let's just get that out there one more time. But also, I think that it's easy, especially in the year of our tech 2025, to think that the fanciest and glitziest and most over-programmed tools sometimes are the ones that we need to use. And simple tools still can be incredibly powerful in and of their own right. It's sometimes just a matter of scale or a matter of data presentation or what have you. So that would be like, don't abandon your simple but powerful tools for something shiny when this really has a lot of life in it. That would be my thing. Brandon, I will risk it and let you. What are your final thoughts?
I guess my final thoughts would be, if you're hosted in the cloud, if you're leveraging some sort of third-party service provider, if you feel like the network is potentially outside of your control and you've given the keys to someone else, and you're looking to get that end user's point of view back, reach out to Catchpoint today. Day one, we can give you the insight that you're looking for, as I showed you from that agent map that we have, as well as the ability to run different types of trace routes depending on what use case that you may have.
Nice. All right, Sergey, take it home.
Brandon stole my. No, I'm kidding. So, yeah, I guess for me, go try out Pietrasanta-traceroute. There are a bunch of enhancements that we didn't have a chance to talk about here. We added congestion control notification in there. We added quick support, and that's a protocol that a lot of applications on the internet, like a lot of modern websites, are going to. There are a lot of enhancements that we didn't get a chance to touch on. Try it out. Let us know what you think. It's open source, so just go do it.
Very cool. Well, gentlemen, thank you so much for joining me on what is the first, but certainly not the last, of Behind the Dashboard. Thank you for our maiden voyage. And I look forward to seeing you back again. And Brandon, you're going to have to report back on Catchpoint After Dark on Fantastic Four. I want to hear how it goes. All right.
Thank you both. For sure.
Thank you both
Thank
again.
you, everyone.
Thank you. Bye.
Bye.
I also want to take a moment to thank all of you for watching this episode. It's no exaggeration to say that there is an overwhelming amount of technical content for you to choose from, and here at Catchpoint, we appreciate the time you've carved out for us. If you'd like to get notified when new episodes drop, remember to use the subscribe button below. For Behind the Dashboard and everyone at Catchpoint, I'm Leon Adato.